The first question in tutorial sheet 1 reads the acceleration a of a particle moving with uniform velocity v in a circle of radius r is given by an equation. A is equal to k r raised to the power of n multiplied by v raised to the power of m, where k is a proportionality constant. Determine the value of n and m and write the simplest form of an equation for acceleration. Yeah, so we need to use dimension analysis to solve this one. So, okay, now let's get into it. So we have A being equal to k r raised to the power of n and m is raised to the power, v is raised to the power of m. So since this is a constant of proportionality, we're going to leave it out as we introduce the dimensions. So I like getting the dimensions from the units. For acceleration, that's meters per squared second. So one thing that you need to note is that this can also be written as meters multiplied by 1 over s squared. From the laws of indices, 1 over anything can be expressed as a negative index. So that's meters per squared second, still the same thing. So meters is a unit for length, so therefore the dimension there is L. S is a second unit for time, therefore the dimension is T. Next, we're leaving out the constant of proportionality. R is the radius, and radius is just a length, so the unit for length is meters, but the dimension is L. Then as for v, this is velocity. Velocity is meters per second, so therefore its dimension is lt negative 1. Right? But let's not forget that these had powers. So this is L raised to the power of n, and lt negative 1 raised to the power of m. Okay, now from here, let's just distribute this m. So that's going to give us lt negative 2 is equal to L to the power of n, L to the power of m, and t to the power of negative 1. Sorry, negative m. So now these are two bases, two of the exact same bases, so we can easily add the powers. So that's L t negative 2 is equal to L raised to the power of n plus m, t raised to the power of negative m. Now this dimension this dimension and this dimension should be equal. So which means their powers are also equal. So that's 1 from this L is equal to n plus m. Then this t has a power of negative 2, and that's equal to negative m. From here, I think we can already solve that directly. Divide both sides by negative 1, or introduce the multiplicative inverse. Then that's m is equal to 2. Then in this formula or equation, we're going to get 1 is equal to n plus m. We already know m is 2, therefore n is equal to 1 minus 2, giving n is equal to negative 1. So we found the values of m and n. Now we need to express the equation in its simplest possible form. Remember, it was a is equal to that constant r raised to the power of n and v raised to the power of m. Therefore, that's given a is equal to k r raised to the power of negative 1 v raised to the power of 2, right, since m was equal to 2. Can be expressed as a fraction over 1. So that's a is equal to k multiplied by 1 over r multiplied by v squared. So that's given A is equal to kv squared over r. And that's how you express it in its simplest possible form. So yeah, that's for question 1.